Introducing librashader. Librashader Runtime Library. librashader is a complete reimplementation of the RetroArch Slang shader pipeline that allows standalone emulators to easily and optionally implement support for RetroArch style shaders and shader presets. I've been sitting on this for a while since the last Snowflake progress report where I teased at the very end, but it wasn't until a few months ago that I nerd snipped myself into investigating the feasibility of doing so. The end result of this effort is a complete reimplementation of a shader pipeline that should be compatible with all shaders and Slang shaders, including the preset parser, the shader preprocessor, and SPIR-V translation, as well as runtime implementation for Direct3D 11, OpenGL, and Vulkan. To be clear, librashader does not rip out the shader parts of RetroArch and just repackage it up, but it's a complete re-implementation with a fully documented Rust API that exposes every part of the pipeline. Why do this? Besides being an opportunity for myself to learn more about graphics API, the main goal of Snowflake has always been to provide a seamless experience to the user without increasing maintenance burden on developers. This is a rejection of the core-based philosophy where developers have to maintain a separate fork of their emulator to service an API, which may fit the emulated console like a square peg does a round hole. Instead, Snowflake's approach is to contort itself into whatever shape some standalone emulator requires, going so far as to compile configuration files, and in the future, perform live editing of emulated memory. That isn't to say the core-based philosophy does not have upsides. RetroArch's excellent shader system is often praised by users for its excellent visual quality and compatibility across cores of many emulated systems. To do some things well, you really do need to reach into the code, and hacking around the issue like Snowflake's attempts to do will only get you so far. However, that does not mean that an emulator needs to coreify itself to support RetroArch shaders. librashader brings the power of RetroArch shaders to any program that can render an image to a buffer off screen. All the emulators has to do at the very end, right before a frame is presented, is to call a librashader runtime to apply the shader passes, and now any emulator can use RetroArch shader without needing to be RetroArch core. How does librashader work? librashader implements the preset parser, which parses .slang p presets, the shader preprocessor, which handles combining multiple shader files into one unit, which can finally be sent to the shader reflection, which actually deals with how to compile the shader for your GPU. This compile artifact is sent to a runtime which deals with rendering the shader given input and output frame buffers. While Rust is nice, it unfortunately is not in wide use in the EMU dev community. But since librashader is a Rust library, it can easily provide C exports for integration in C and C++ projects, which the majority of popular emulators are written with. To make things as painless as possible for emulator developers, librashader is distributed as a dynamic library intended to be loaded at runtime. A header-only C loader, librashader_ld.h, is designed to be a copy and paste into your project, which loads librashader function pointers from an implementation. If not implementation is found, then the loader will do nothing when the functions are called. Complete documentation is provided for both the C bindings and the native Rust API. I don't want to prevent commercial, permissively licensed or closed source projects from using librashader, but I also want to encourage contributions to come back to the project. To that end, the implementation of librashader is licensed under the Mozilla Public License 2.0, whereas the C headers and only the headers, including librashader underscore ld.h, are licensed under the MIT license. This allows librashader to be used in commercial, permissively licensed, and closed source projects, as long as any modifications are open sourced and make it back to the community while staying non-viral. Caveats. The biggest caveat is, of course, that librashader still requires support from emulator developers, and I do not want to force anyone's hand via hostile forks or otherwise less than polite encouragement. Code changes will be needed to bring in librashader, and while I have designated the library to be as non-invasive as possible, such code changes may not be trivial. For any developers that are interested, please reach out to me via GitHub or Twitter if you encounter any bugs or issues while exploring librashader. librashader supports less platforms than RetroArch does. I do not have a personal macro OS device to develop a Metal runtime for, and develop the Vulkan runtime was a month-long slog for me. Having known next to nothing about Vulkan, which has left me too burnt out to touch a Direct3D 12 runtime at the moment. I hope to revisit D3D12 soon in the future after switching gears and taking a break. There are some additional technical caveats listed in the README that is more helpful for developers, but I don't foresee any actual issues in practice outside of any actual bugs that come up. And of course, librashader is currently in beta, with all the versioning finicalness that entails. I am open to suggestions on how to improve the API, and I'm hesitant to finalize a 1.0 version without librashader seeing wider use and feedback from other developers. One thing I could think of right now is a need to improve logging, but I need to think on how to create a good logging interface without clogging up standard output for an emulator. There's some additional finagling involved, as well as due to differences between Rust and C/C++. Future work. A Direct3D 12 runtime would be nice to have. All the runtimes are fairly similar in structure, so I think I will quite easily be able to do will be able to support D3, D12 soon, but I do need to take a break, play some actual video games, and touch grass. I had originally planned to release this by Christmas, but the Vulkan runtime was taking me so long to find the motivation to complete. In the more distant future, I'm hoping to move the shader compiler and reflection infrastructure from SPIR-vcross and shader C, which are Rust bindings to C++ libraries, to Naga, which is written in pure Rust and much faster than SPIR-vcross and shader translation and reflection, meaning shorter load times for shaders. Moving to Naga could bring support for a possible web GPU runtime. There are also plans to omit DXBC/DXIL completely, bypassing FXC/DXC and HLSL compilation, which would potentially lead to faster load times when loading shader presets to Direct3D. However, this is currently blocking on combined image sampler support on GLSL parsing and lowering to shader languages that don't support combined image samplers like HLSL. You can find librashader on GitHub. That's it.